When you have a triangle that's not right, it's either an acute triangle, all of the angles are acute angles but add up to 180, or it's an obtuse triangle. One of the angles is obtuse, the other two are acute, but none of them are right. Kind of saw some of those things, if you can remember, all the way back to the beginning of chapter 9 when I had you do like triangle and list out facts. Okay, so those are types of triangles. Okay. And this has to be true. And these things we should kind of agree with from geometry. Like, in order to be able to solve a triangle, meaning find missing angles and missing sides, you have to know at least one side. Do you remember back in geometry when you did things like angle, side, angle, 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 side, 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 side? Okay, those were congruence postulates so that you could prove two triangles are congruent. We're not doing those here. But there was one theorem or postulate that was something angle, angle. Do you recall that? Angle, angle. And then you wrote angle, angle. Okay. The angle-angle postulate or theorem is not for congruence. If you only know two angles of a triangle, then you automatically know the third angle. But if all you know are the angles, you have no idea the size of the triangle. So you could have the same angles and all the side lengths be small size, or you could have the same three angles and have all your side lengths be 5 times that, so large size. So angle-angle was a similarity postulate or theorem. You could prove that two triangles would be similar, that they would have the same shape because they shared the same angles, but you couldn't say that they were congruent because you didn't know what any of their sides were. So you need at least one side. Okay. Then you need two other parts of the triangle. In order to be able to fully solve a triangle, you've got to have at least 3 pieces of information. If you don't have 3 pieces of information, you just don't have enough to really say what that one triangle is. Maybe there will be lots of different triangles that could work. So you got to have 2 other parts. Now those 2 other parts could be more sides, or it could be angles, or it could be an angle and a side. Okay. So not to be confused with congruence postulates from geometry, but when we talk about solving triangles, we often say, you can solve it, and again, you don't have to necessarily write all these down. You can solve it if you have an angle, side, angle. So, if you know one side of the triangle, and then you know the 2 angles that sort of are on the end of that side, you'll be able to find the 2 missing sides and the missing angle. You can also do that if you have angle, angle, side. So you know 2 angles and 1 side. You can solve triangles through side, side, angle, which, if you'll remember, that's not a congruence postulate. Did your geometry teacher ever tell you there were no bad words in geometry? So you couldn't spell ASS? Okay, always write SSA on the board. If you want your one free chance to write bad words, go for it. I will not be offended. Okay, I just won't write it on my board. But you can write it all over your papers and quizzes and tests if you want. Okay, so if you want to feel rebellious, this is your moment, all right? Free reign. So, while we can't prove that triangles are congruent doing that, we can, if I know 2 sides and an angle that's we say non-inclusive, so it's not in between the 2 sides, I can actually find the missing sides and angles. So a side-side angle problem, it's set up, would be I know this side is 5 and this side is 6, and then I know this angle is 30 degrees. So I call that side-side angle because I have 2 sides, but my angle is in between them. It's on the side of them. Okay. So that's side-side angle. And we are allowed to solve. We can solve triangles if we know all 3 sides. That's going to be actually tomorrow is the law of cosines. Okay. And then we can also do, similar to our bad word, if you know 2 sides and an angle, you can solve it if the angle is in between. So really, I think we've kind of covered all the different like possibilities here except for angle, 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 right? Because you have to have at least one side measured to be able to solve the triangle. So if you just knew 3 angles, you wouldn't be able to find the side lengths. But if you knew one side and 2 other parts, no matter what it was, you would be able to. Okay. I think we'll get to the first 2 today, and these 2 will be tomorrow with the law of cosines. Okay, let me see what's on my other slide. Do you want me to do my other slide? Yeah. Okay. This is the law of sines. Not connected. Move everything down. I probably have the habit in a lot of the notes to just copy and paste this triangle, and then I changed my A, B, C's, and D's to be numbers. So, like, you'll constantly be seeing my triangle sort of looking the same, but you can really draw your triangles however you want. Even if you draw it like as an acute triangle, and then you find out one of the angles is obtuse, that's fine. You know the angle is obtuse because you did the math, but your picture doesn't have to look like that. So you really just need 3 sides and 3 angles. A, B, C, label them accordingly. And this triangle is not a right triangle. So maybe this looks like it could be 90 degrees, but it's not. So it's either acute or obtuse. We would have to solve for it. Okay, now I'm going to kind of walk through how you generate the law of sines, and then we'll put what the formula is for the law of sines. You will be responsible for the formula for law of sines. You won't have to like generate the law of sines on your own, but it's just kind of nice to know where it comes from. Okay, so do we all agree this is not a right triangle? Okay, so this is not a right triangle, but I can make right triangles. Okay, I could, we call this what, an altitude in geometry, when you take from the vertex B and you drop it to the side such that it creates a perpendicular line to 90-degree angles. And so now I have, can we call this the height of the triangle? Some new unknown to us, some height. And if I cover up the triangle on the right, if I focus on this triangle over here on the left, I could solve for the height because I would know this side C and this angle A, and that would be opposite and hypotenuse. So I could make an equation that says if I knew the sine of A and I knew side C, that sine A was H over C. And in the other triangle, on the other side, I could also solve for height. I wouldn't want to use this B because B goes all the way from C to A, right? So I'd be wanting to use the height and A. And then if I use this angle down here, sine C, that's another opposite and hypotenuse. So I could say in the triangle on the right that the sine of C is equal to H over A. Okay. And both would be valid. So whether I knew, angle A and side C, or whether I knew angle C and side A, I would be able to solve for my height there if I wanted to. Well, notice in these 2 equations, what do they share in common? They both have sine. They both have H, right? So, algebraically, I could solve for H by multiplying by C on both sides. H is equal to C times sine A. And over here, I could solve for H by multiplying by A on both sides. Now what can you do? Two things equal to H. Then what must be true? Delaney? they're equal to each other. That's which property? Do you remember? Transitive property. If C sine A is equal to H and H is equal to A sine C, then C sine A is equal to A sine C. So now I can say C sine A equals A sine C. All right, well, what I like that's sort of happening here that's kind of interesting is, do you see on this side we have side C and angle A? And on this side we have side A and angle C. I'm going to like do some algebra just manipulating my equation so that the C's are on one side. They're different measures. One is an angle and one is a side. And the A's are on one side. So I am going to, I'll divide by sine A on both sides. So that sine A and sine A cancel out, right? And then I'll also divide by sine C. So that sine C and sine C cancels out. And this is the beginning of the law of sines. Okay, I'm going to use my symmetric property and flip these left and right. A over sine A equals C over sine C. What that says is, if you know angles and sides of triangles, the side length over the sine of its opposite angle has the same ratio no matter which angle and side length you're looking at on the triangle. These ratios will always be equal. So if you know 3 parts of this, then you can plug in the 3 things you know, like the 2 angles and 1 of the sides, and you can solve for the missing side. Okay? Or if you know the 2 sides and 1 of the angles, then you can plug in for those and solve for the missing angle. Now I'm not going to take the time to do it, but I could go back up to this triangle. So this would be a good challenge for some of us who kind of are like interested in this theoretical sort of proof making, where a formula comes from. I could go back up to this triangle and I could draw a new altitude. And I could, so that I don't have A's and C's, I'll either have A's and B's or C's and B's. Okay. And what I'm going to find is, to finish off the law of sines, this is the full law of sines, that's true for the B's as well. B over sine B equals either the C over sine C or the A over sine A, whichever way you tend to draw your altitude. But then by transitive, they're all equal to each other. So make sure you get this final formula down. This is the law of sines. And this is a good place where some of us may mark in our notebook. Let me go back to that triangle at the beginning, and instead of going from, what did I go from, vertex B? So instead of drawing from vertex B, maybe I'll draw from vertex A to the other side at a perpendicular, and I'll try to set up my law of sines, or I could go from vertex C. Okay, but I'm not going to take the time to do that. Okay, you'll just have to believe me for right now. These ratios are all the same. Okay, does that look familiar? Have you ever seen that? So not in geometry? Okay, so this is new. You will be responsible. I think our test is scheduled for next Wednesday, because we have, I think, 2 days of review. So you will be responsible for law of sines. So as you practice your homework, make sure you're thinking about, do I understand this formula? It's really just a set of proportions the side over the sine of the angle. Okay, let's do an example. Nope, I copy and paste my triangle. Doesn't really matter what your triangle looks like. You just need 3 sides and ABCs. You cannot go wrong with a triangle. Okay, so notice in this triangle, we do know one side, right? Which is essential for us to be able to solve the rest of the triangle. I know 3 things. If you want to, you can write out like the 6. I think I did this back when we were solving right triangles. You can write out the 6 things that you should know. 3 angles and 3 sides. And if you want, you can fill in like B is 118, C is 36, and what side is that? 14? I'll be side C because it's opposite of angle C. So we'll say C is 14. So you have to find angle A, and you have to find side A and side B. Okay, what do you guys want to solve for first? Angle A, that's an easy one, right? So we know 2 angles, add them up, subtract from 180. Let's see, what are we going to get? This would leave me with 62 if I subtract that, right? And then subtract 36, so 32 and 26. Okay. 26 degrees. So we can fill that in. Do you want to solve for side A or side B? A. It does not matter, okay, right now which one you choose. So we're going to solve for A first. So if we're trying to find side A, then we would want to create a ratio with A. So we'll say side A over the sine of angle A, which we just solved to be 26 degrees, is equal to, and I don't want to use the B's because I have nothing to put in for B yet. I don't know what that is. So I don't want to put another unknown in my equation and have B over sine 118. Then I can't solve for A or B. So then I'm going to use the other ratio, the C's. C over sine C, which would be 14 over sine 36. So even though the law of sines comes out with like that 3 things, you're really only picking 2 of them at a time. Okay, how do you solve something? I call this a proportion. How do you solve a proportion? Cross multiply. Yeah, when you have an equal sign in between 2 fractions, you can cross multiply. So we'll get A times the sine of 36 equals 14 times the sine of 26. It does not create a fraction, it creates another equation, equals equals. Those are the means and extremes of your proportions, if you remember those vocabs. And your goal is to solve for A. Since A is getting multiplied by the sine of 36, we have to divide. So now I divide both sides by the sine of 36. Sine 36 will cancel. When you're typing this one into your calculators, be careful. If your calculator puts a parenthesis for the sign, make sure you close it before you divide, because you want that to be like in the numerator. If you need to borrow a calculator, come grab one. My missing calculator was returned during 5th hour, so all my calculators are happy. They get really lonely when one of them is gone. And someone, let's round to the 10th. When you get A, tell us what you got to the nearest 10th. We'll see if we can get anyone to agree with that.
got 10.44.
So can I say 10.4?
Yeah.
Did anybody second that?
Yeah.
Okay, so if you're not getting that, like check around with your neighbors or raise your hand. I'll come look at what you've typed in. Remember, closing that parenthesis is really important. Okay, so now we know side A is 10.4. Okay, just make note. This was not a right triangle to begin with, and when we solved for our missing angle, there were no 90-degree angles. You cannot now use Pythagorean theorem. Pythagorean theorem only works if there's a 90-degree angle. So to find your missing side C, missing side B, because we've got 10.4, you're going to set up another law of sines. Okay, so we know that A is 10.4. So now I'm going to do C over sine 36 equals, you could use the 10.4 that we just solved for, but remember Maddie said it was like 10.44, and there was probably a bunch of other numbers after it. So I always recommend go back to the one that you knew in the beginning because that's exact, right? So your answer will be less rounded. So I'm going to set it equal to, oh, I put the wrong number and it's 118, isn't it? I'm solving for side B, aren't I? Sorry. I got C in my head. I apologize. So we want to find side B. Side B. Goodness. Side B over sine of angle B is equal to 14 over sine 36. And then the process is the same, right? Cross multiply and you'll end up dividing. So I'm going to get what? B sine 36 equals 14 sine 118. Divide by sine 36. And you guys type that in and tell me what you get. Oh, what'd you get?
21.0.
So I'll round that to 21.0 or 21. Anybody confirm Alex's number? Got that too. Okay, I'm seeing lots of hands up, so that's great. Okay, now here's something really interesting that will pay off later. One way you can kind of see if your answers even make sense. Okay. Across from the smallest angle must be the smallest side. It works. Across from the largest angle must be the largest side. Still working. And then the medium angle would have the side that's in the middle. If you ever solve a triangle and then like across from your obtuse angle is a smaller side that's something else, there's something wrong in your calculations. Or law of sines has this really weird thing called the ambiguous case, where there could be two triangles, so you want to watch out for that. But we won't get to that now. I think you do that in Algebra 3 or pre-calculus. So ours will be one triangle only. We'll be okay with that. Okay, last example. So this one was an angle side, angle or angle angle-less, angle side. It was actually this one because the side 14 wasn't in between the two angles. But because you knew two angles, then you're really solving an angle side angle too. Let's do one. Let's skip that for right now. Of the bad words. Side angle. I may show you, I think I'll wait, I'll save the ambiguous case. I'll show you that visual tomorrow. Like why something weird can happen. Why I'm urging you to like just look and see that the smallest side is across from the smallest angle. Like that should make sense. Of course, yours will turn out that way, but if it's an ambiguous case, it could be not that way, and that means something's wrong. Okay, so remember, this is side angle, so it's different than the last one. In the last one, I knew two angles. This one, I know two sides. Let's see, so B is 79, side C is 9 and side B is 16. Okay, well, don't jump the gun and do Pythagorean theorem because you have no knowledge that you even have a 90-degree angle, right? So we can't do Pythagorean theorem. We're gonna have to solve for something that's unknown to us. The angles aren't as easy as they were last time, right? We don't know what they are, just that they add up to 101 degrees. There's a lot of pairs of angles that can do that. So when you maybe like don't know an angle that makes it like really easy, look at your triangle or look at your letters and which one has a match, like the angle on the side. The B's, right? We know angle B and we know side B. So we're definitely going to use that in the law of sines because it will be a one complete ratio. So something equals 16 over the sine of 79 because that's side B over angle B. Currently, the only other information you know is about side C. So the first thing that we all have to solve for, we don't really have a choice on this one, we'll all have to solve for angle C first. So we'll make the ratio 9 over sine C. Okay, still a proportion, so cross multiply. We'll get 9 times the sine of 79 equals 16 times the sine of C. You're trying to solve for C, and the sine of C is getting multiplied by 16, so we're going to divide by 16. So the 16s cancel. I'm going to do my symmetric property again and swap these here. The sine of C is 9 sine 79 divided by 16. You can't divide by SIN, sine. You have to divide by the sine of an angle. So you'd have to divide by sine C, which isn't going to cancel out. So there's no point in doing that. We have C, which we're trying to find, and it's trapped in a sine. So we have to undo the sine. What do we have, tool-wise, that will undo a sine? The inverse sine. So you can think about, you know, like how we if we see something added, we subtract from both sides. If we see something multiplied, we divide both sides. So if you want to think about this right now, you are going to arc sine or inverse sine both sides. Now, I don't mind, like for me personally, I'm okay doing second sine in my calculator. Okay. So I'd use my second sine. And that's, of course, going to bring up my sine with the -1. And then I'll just type in the rest of the stuff, right? So I'll just do 9 sine, if it brings up the parentheses, close 79, divided by 16, close my parentheses for inverse sine. If you want to give that a go and see if you can get the right answer, cool. If you really feel like a little overwhelmed, you could type this part into your calculator and get a decimal. I would say don't round it then. Like use as many of the digits as you can. That way you have a more exact answer. So when you inverse sine, put in a bunch of numbers after the decimal. Anybody got an angle for C for us they can share and we'll see if we agree? Jayla? 33.5? I'm getting some thumbs up. See if you can get 33.5 in a calculator. Consider this like a muscle memory. You got to type it in once and see if you can do it. I don't know if you can do it. You have to do it, and then you got to let us know if you can. Otherwise, I mean, we won't know until you take a quiz or a test. So it sounds like 33.5 would be right. I typed in second sign to get the inverse sign. And then I'm okay with just doing 9 sine 79 divided by 16 after that. That's just going to give me the exact value of whatever that is. If you type 9 sine 79 divided by 16 in the calculator, it's really a decimal. So let me do that one. 9 sine 79 divided by 16. Okay, so if you're not going to type that all in, then I would want to see you do more work, like inverse sign, more decimals, or numbers after the decimal. 0.55, 216, 5291. It's probably only going to change your answer by 100th or a 10th, but we're striving for more exact answers as we level up in math. So we want to avoid rounding in the middle of a problem. Are we getting 33.5? Okay. Now, if you solve for 33.5, what can you do now? Find angle A really easily. Now you're just subtracting from 180, aren't you? So can someone do that for us? 180 minus 79. Jayla?
I got 67.
67.5. And then you can set up another law of sines. So you might say, I'm going to squeeze it in up here. Let's see, side A over sine 67.5 equals, I'm going to go back to my original 16 over sine 79. I just like keep reusing that same ratio every time I do the new law of sines. And this is going to be A equals 16 sine 67.5 divided by sine 79. I'll cross multiply, so it'll be 16 times sine 67.5. And then when I cross multiply over here, I'll be multiplying A by sine of 79, so I'll need to divide by that. If you've got a decimal answer, give it to us, Maddie.
15.1.
15.1. Any verifies? Remember, you can do that check. I'll talk about this tomorrow, the ambiguous case. But the smallest angle is opposite the smallest side, 9. The largest angle, 79, has an opposite side that is the largest, 16. And 67.5 is in the middle, it's 15.1. But it is closer to 79, so it's a little bit closer to 16. Okay, so there's some kind of connection there, right? All right, your homework assignment for law of sines is in that worksheet packet that you got last week. It's the last page. It's the front side only. So you've got law of sines on the front. You've got law of cosines on the back. After tomorrow, we'll have all of our information for Chapter 9. We're going to do some work stuff with law of sines, law of cosines, probably also additional review from Chapter 9. I think we have 2 days on schedule for review of Chapter 9 and then a test on Wednesday. So that's a lot of time for the test on Wednesday to have all the information and be able to study. We got just a couple of minutes left, but make sure that you put that worksheet somewhere. When I come around, I'm going to expect to see work, not just answers. So make sure that you're like showing your setup for the law of sines so that you can get full credit on that homework assignment. Oh my gosh. You know what? With 2 minutes, I'll give them back to you tomorrow. I'm sorry. I forgot.